Okay, good morning. Welcome to
Counting number 10A.
Counting number 10A. So this is an example problem from Art of Problem Solving's Introduction to Counting and Probability book. And we're just talking about it today. And you guys are seeing this problem for the first time in the Counting with Restrictions chapter. I thought it'd be very interesting to hear how you work through this.
Okay.
So the question is, the Smith family has four sons and three daughters. 3 daughters and 4 sons. How many ways can they be seated in a row of 7 chairs such that all 3 girls sit next to each other? Okay, do you guys understand the problem?
Yep.
1, 2, 3, 4, 5, 6, 7. Yeah. Okay. Do you have any questions about the problem before you get started?
No.
I have one question for you. Can you hand me my coffee? Thanks.
Alright, so the 3 daughters can be seated. They have to be seated next to each other, so they can be seated here.
They can be seated one over
here.
There.
Here. Here. Then this one. And that's it. So 1, 2, 3, 4, 5.
5.
There's 5 different arrangements, but I'm going to use this one. So, the 4 sons are seated here.
And they can be seated in 4 factorial ways, so 24 ways.
But the daughters can also be seated differently. Because there's not any particular order they have to be seated in.
Okay.
3, 2, 1.
So that's 6 times 24 ways. It's a 144.
Ooh, interesting. Have you ever seen that number, 144, before?
It's
12 squared.
Why is 6 times 24 the same as 12 times 12?
Because you can take a 2 out of the 24 and put it in the 6 and you get 2 12s.
Cool.
Pretty neat way to multiply that.
And in addition, we said there were 5 cases that you could slide this group of 3 down.
Okay.
So you have to times 5.
I think that's 720.
Okay.
See, 500,
And then
200,
20.
and 20.
All right.
720.
Interesting. Have you ever seen that number 720 before?
Well, that is 6 factorial.
So why is 3 times 2 times 1 times 4 times 3 times 2 times 1 times 5 the same as 6 factorial?
Well,
we have
because
we have 3 factorial and a 4 factorial.
And a times 5, don't forget.
So we start with the 4 times 3 times 2 times 1.
And we could have added the 5 one to the end.
We add 5
times
and this 2 times 3, which we can write as 6.
Look at that. So there it is.
Oh.
There's the 6 factorial. Okay, hey, that was really, really good work, guys. So you found that there were 5 separate cases. Are there any overlaps in those 5 cases? Why not?
Because you're always sliding.
A different way.
Okay, because the 3 girls are in the separate cases. The girls are never in the same spot.
Yeah.
Okay, so there's no overlap. Great work, guys. Great work. High five. Oh, not you, not Mr. Pink Eye. Good job.